Hello and welcome to wasmCloud's community call for June 3rd in 2026. We've got a pretty full agenda today. A lot of it, I'm just going to go through some of the things we've landed over the past 2 weeks and why we revved basically to a minor version for v2.3.0. And it obviously had a lot of stuff. If you go look at the generated notes, there's even more stuff. So I am just trying to highlight some of the things that I think are above the fold, but there's plenty more to be called out here. So um, before I dive into that too much, do we have any other agenda items that folks would like to add before we go too deep? If not, I'll keep going. All right. Okay. So there were a lot of different changes that we landed. Um, the biggest one that I want to first highlight is that we made it so that it's really nice from WashDev to be able to pass in configuration, secrets, and environment variables into your config YAMLs. And we've got an example for that. So if we basically go to our examples here um, inside our repo and jump into this one specifically. This is the hotel config example. We'll walk you through how to basically build a component that deeply uses hotel. And I've given a demo of this one before, so I'm not going to run through that one necessarily, unless folks want to see it. It's easy to run. But essentially, we've got the component path that we're running, the address that we're using local blob store key value backed by a file system. We're able to pass in an environment variable that describes the exporter endpoint. And so these values, this environment value is passed to the dev host. So these are all dev host configuration values. And then for these are the workload configuration values. So the environment variables that the guest gets, the environment, the secret that the guest builds off of. And we basically use Docker Compose syntax for how you can refer to these either from an environment variable like this or from a file like that. And so that feature has landed and you are welcome to play with it. Part of this was also making sure that we fully restrict allowed hosts. So potentially, when you're running this, you might see a relevant error that we have docked here that if you run and this demo by default actually reaches out and talks to example.com or httpbin.org. If you haven't added it as one of the allowed hosts that this workload is permitted to speak to, it'll give you an error basically saying that. And so if you want to try that out, you can also use this exact same demo for that. And there's one other major change that we made here that I think is worth knowing about, which is essentially we now also do trace propagation. And that basically means that when we're running across multiple different hosts, or maybe even propagating a span between different workloads that aren't even WebAssembly workloads, but are all interacting with the same thing. If you run this exact demo with the exact same component, but passed in with a different config URL for each one. And I'll show you how that works. Essentially, you can see that with 3 different instances of WashDev, with their different configs, that we're able to basically propagate those traces. And each one is attached to the same call chain. And the main trick here is, as you can see, we're passing in for the exact same example component, but with this special configuration for each one. And if I pull up their config and I go to chain, and then all that's in this chain is actually just their config that we're passing through. And you'll see that this one's basically the same, except the address is specific to, like for this one, this is the backend address for 8002. And this one is going to reach out to example.com. And I'm only going to pull up one other. So let's do the front end. So coming in through the first part of this call chain, and this one is serving on 8001. and it is going to make a call basically to the next hop in this chain. So right here. So serving on 8,000, calling 8001. And so that's how you get basically this chain. And so now you can actually see that propagate through on each of your spans. And all of that will map to one single trace, which is nice. So that is sort of a good chunk of some of this work. Now, one thing that has solved a lot of different issues for folks is that now we've changed the way that we build our test infrastructure. And so I just want to make sure people are aware that this has changed. So we're now using xtask inside wasmCloud. And right now we only have one task that is using xtask, and that is our build test fixtures task. So this basically builds our tests over here, a bunch of different WASM type tests. And it fixed a whole host of issues where basically we had cargo and cargo. If you're familiar with Docker and Docker, it's kind of like the same sort of thing where except cargo is very, very, very specific about being able to do one thing and one thing well. And this was probably one of the roughest edges that most people reported when they were getting started with wasmCloud for the first time. And we were able to close out a ton of those different issues. It's a little bit harder to capture since a lot of them are old. But essentially, by doing this, decoupling it so that it's something that runs out of process. The first time you clone wasmCloud, just make sure you run this, and then you're able to basically run our tests straight off of that. And this was one of the blockers for something else that we've been cooking for a while, which is our bench infrastructure. So once we had that in place, we now have something kind of neat, which is we're running off of every release. We are now triggering a bench run on a hosted Baremetal Hetzner. It's a AMD Ryzen 5. Yeah. Oh, hey, there it is. So it is tuned for doing performance benchmarking, and now we have actually two different types of micro benchmarks that we're running against this. This one is a Criterion benchmark. So if you wanna find our benches inside our repo, let me drop I guess a link to that. But essentially, if you're running locally, you would just say, yeah, let's do this one. Oh, let's do HTTP invoke. So I'm not actually going to run it because I'm going to keep talking. So I'm giving it a no run. But essentially, if you ever want to run the benches locally yourself, you can turn on or off WASI P3 for the bench if you want to use it, and then you get this run. And so as you can see in these benchmarks, we're running it with P2 versus P3 for a handful of these, looking at HTTP throughput, the difference between cold and hot invocation, and with this other benchmark. So right now I'm running this HTTP invoke one that we just ran here. With the other one, it's actually callgrind based, which is part of valgrind. But it's going so slow. The project got renamed from iai-callgrind to gungron. But effectively what it is counting instructions. So it has a much better deterministic profile. It's not going to have as much noise. The downside is that when you read this, it doesn't quite make a lot of sense, versus when you read this one, you see wall time. So that's something that's easy for humans to understand. And you can measure things like requests per second, whereas instruction count doesn't mean too much to most people, but is also super valuable when you're trying to like really measure things that are happening within nanoseconds. Yeah, Frank.
Oh, this is wonderful. One question: did you run this with Tau enabled?
Did I run it with OTel enabled? I did not pass it an OTel collector, so I did not have OTel enabled.
Okay, I was just curious to see what will be the impact of when you have Tau enabled.
Yeah, the way our host works is that it if you pass in an OTel exporter to it, it will say, okay, I'm going to enable basically the OTel plugin. And when we run these benches, well, actually, you've got a full run book if you ever want to try to replicate benchmarks, because benchmarks are useless unless you can actually replicate them from other people. But for us, it doesn't even have an OTel stack attached to it or anything like that. Uh, I would also say that OTel does tend to have a pretty significant performance impact anytime you've enabled it, but it also depends greatly on like how much sampling you're doing. I would also do that more as a K6 like macro benchmark rather than these, which are very, very tuned to be micro benchmarks. So like, oh, not these. Da, 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 here. Got a couple different crates for it, but um, all the stuff that we're using to measure this, so like the way that I'm displaying it on the page is that I've got Criterion, which is the one that has the wall time, and callgrind, which is the one that's also called gun that is doing the instruction counting. These are very much like if you actually look at what the benches themselves hold, are super tuned to like I'm just trying to measure component composition. Like I'm not trying to measure the whole world in a micro benchmark. In this case, HTTP invoke is very specifically like trying not to include any kind of extra additional network noise beyond the direct HTTP call. I don't want anything else in that path because I only care about our actual throughput inside the runtime. Everything else just
It,
introduces
it,
noise.
yeah, so it definitely makes sense, but I was just curious to see if you somehow measure also the impact of hotel. So maybe that's something to do offline.
Yeah, well, adding new types of bench is now super easy, and it's like just through a matrix. And the runbook also includes like how to add more benches. I expect us to have a ton more different kinds. Now, the caveat there is like as we add more, then the bench runner is going to take more and more. So we should be careful about like what our like golden path validation suite are for these. Um, However, being able to add new types of experiments is really important. I do also want to highlight, actually, as people experiment, especially for maintainers, one thing that I added is the ability to actually compare direct against refs. So let's say you did add um, your own basically like new benchmark that you wanted to validate. And in this case, I wanted to test Gungron. I upgraded versions. And so when I want to compare against that, I go to compare here, and here's the two runs that I did from this run here. And that'll show me that these are basically the same. There were some variances in that run, but it was below the threshold of like considering it a regression. And you do expect some changes, especially if you're doing the Criterion version versus the call grind. But anyways, as people make PRs, you can actually trigger this. So anytime we think we're doing something that's performance sensitive, you can pass in the SHA basically of the PR that you're building against or the branch of that. And this will go and run it on the host for you and do a comparison between that and like main, which is pretty nice. So, um, and as you could also probably I went too fast there, but this one has it too. As we add other benches, you can decide exactly which one you want to run as part of that trigger, and you would just only be running that set of benches that you think you're doing the experiment on. So if we wanted, we could add OTel, for example, right here and start measuring that one a little bit closer.
Okay, thanks.
So that's the new benchmarking infrastructure. Something else that we did is we added basically whenever you get a span, you'll see WASI.blobstore or WASI.keyValue as a prefix to your span. So before we would say things like get data or get container, and it wasn't obvious which plugin was surfacing it, which interface. So now we have an easy common way for all of the host plugins that are built in to show exactly what they're surfacing as part of their spans. We upgraded to Wasm Time 45. We upgraded to WASI Hotel RC2. Now this one is pretty cool. Jeremy added basically namespace scoping for our operator for a lot of the things that we deploy, and we also now have tests that basically say if anytime we expect everything to be namespace deployed and it's not, and it's cluster role, we will regress and we'll flag that. So we've got some good guards around it now. Any more you want to say on that one, Jeremy?
No, no, you completely covered it. And really what was driving that is, obviously like the financial organizations, the governments, like ones that like environments that are very, very secure, they really hate cluster scoped namespacing. And so that was the whole driving factor for this one.
Yeah. So I think, I still encourage people to keep using this stuff, giving us feedback. We're able we have a pretty nice pipeline now for end-to-end test integration for our operator and how it deploys. And I know that part of that, and I showed this off in a past community call, is that we now also have fuzz testing for our operator. And where we want to have fuzzing is basically especially focused on where we're passing in host interfaces inside our workload deployment YAML, validating the serialization, deserialization, that we don't have any kinds of panics within our operator. So that's now also continuously running. We also now produce a WASI P3 Canary image. So if we go out here and we go to our packages, and I open up the wash one slowly, you'll see that we now have a canary for WASI P3. So we're getting really close to launching WASI P3, like potentially as early as next week. And if you want a host that has P3 enabled by default, it's this one. And you can just start using it. I did not do the binaries. I only did the OCI. But once P3 is launched, we're going to flip this on to be enabled by default for everybody. And so there won't be this separate canary image. It'll just be the normal canary and it'll have WASM P3 inside it. Some folks have trouble building all the different Rust dependencies that we have themselves. If they're in a regulated environment, there's a lot of different dependencies that come in. And so yeah, that helps them quite a bit. Let's see what else we got going on. We got a lot of different changes. I showed that one, showed you the demo for the hotel trace rollup. Let me just drop this example in the chat for folks to try out themselves. Pretty happy with how it turned out. And then for the last bit, I wanted to make a call to action. So basically, WASI P3 is getting close to being ready. We have this tracking issue for our WASI P3 work, and something that we need more of is some good examples and templates for starting with P3. I think I strongly recommend starting with Rust. We're not quite ready for TypeScript yet, although I understand that that's getting very close. And then we could stand to do a big documentation pass on wasmCloud.com on some of the differences between P3 and P2, and get ready for a blog post for that. And since all that's happening basically next week, now is a really great time to give me feedback on if this is all working for you or if we've got some big problems that we need to address post haste. So just wanted to make that big call out. And then this issue, Jeremy's going to pick up next, I think. I'm going to drop that one in there if you want to talk about that one, Jeremy.
No, actually, I mean it's pretty self-explanatory here, but I mean this was opened early January, and really just continues the wasmCloud V2 journey to Kubernetes, and this is really just around auto scaling. There is some crude rudimentary auto scaling you could do today, but this really just aligns it with using the horizontal pod autoscaler that's used for container type deployments, so that your Wasm workloads can be handled the exact same way.
Cool. Yeah. With that, and basically the xtask change, there was a bunch of different reported issues and bugs that we had on our roadmap to resolve that wrap that up. If I go to our project board, where we're at right now, which we have 1 month to complete this out, but we've done a ton of work here in our Q2 planning. And so basically Jeremy's taking that one. We've got a couple others assigned. So There are a few that are a bit blocked. This one is basically waiting on P3. This one I can give an update on. Alex has landed a lot of the changes inside Wasm tools and then has a PR up in Wasm time that I'm code reviewing right now. And we'll try that out inside wasmCloud. So I think that one is actually on track. I think this one we can definitely also complete inside this month. A lot of these others are a little bit smaller. There's obviously more work to be done for a benchmarking suite. I've obviously showed you a lot of the benchmarking infrastructure. The next pass here on this one would be probably K6 with a macro benchmark. I was able to quickly add a prototype of that, but I didn't have time to like take it all the way over the line. So that one's probably a good one to take at some point, but should be easy to add to basically our existing benchmarking infrastructure, and we can mark that one as done. I think this one is going to be needed sooner rather than later because we're starting to see this really great growth of languages that now support GC, and it's not enabled by default yet in WASM time. So being able to flip flags like that on is going to be super high priority coming soon. I think this one's very tractable and straightforward to implement. So I think we'll see that one land probably over the next week or so. And yeah, so anyways, that's our roadmap update. I think we're very much on track. Once we land host component plugins, I think the others, like I called it out for secrets somewhere in here. Yeah, this one. That I think this one would be a really good candidate for a host component plugin. And so some of these are kind of, there's a little bit of a dependency chain here, but I think for the most part, for us to get all of this done in Q2, we're on track. Whew. And that is it for the rundown for where we're at with wasmCloud v 2.3 and P3. If folks want to, Liam, did you want to share some of the updates you've been doing on the DevRel side? I unfortunately saw that he just now went off camera, so that was kind of bad timing, I guess. Oh well. Any questions, folks? All right. Well, with all that, that is basically it for planned content today. And also, Aditi wasn't able to join. Everybody send him good vibes and good luck because it's finals week for him. So, uh, good luck, man.
Billy,
Cool.
I apologize. My daughter's school called.
Oh,
She
yeah.
was like literally we went to hand me the mic, I think. I
Yep.
threw you on mute, so I apologize. I can do my demo now.
Cool.
If we want.
Yeah.
Um, just a quick update. We've been doing a ton of work behind the scenes here with wasmcloud.com. And Eric has been doing yeoman's work in landing just a lot of just long-term cleanup and documentation tidiness. And there's a few things that we're doing here behind the scenes. One of the big efforts is to make WebAssembly and Wasm Cloud more accessible by LLMs and to enable them to self-discover docs, tutorials, and things like that. So we've been landing not only JSON LD behind the scenes for every page that should land here in the next day or two, but also we've done a huge revamp on not only community pages, but even on our YouTube channel itself. So as you go back in time, you'll start to see that now there is an AI generated summary with chapter links for every meeting. And then this is now reflected all the way through into YouTube itself. And what we're trying to do here is just make the content that we're generating here on a weekly basis more discoverable, easier for folks to access, to cross-link these things better. And then there will be some work to take each doc page here once we land JSON LD, and then to to link back to community meetings and demonstrations here to say, hey, this was discussed in this meeting. Maybe we'll do it as a sidebar component just to let people, pivot back and forth between the resources that are better here. So it's been a lot of work, but with some of the new AI plugins, we've been able to automate a lot of the heavy lifting behind the scenes here to get this done. Any questions? Okay, great. Yeah, just pretty straightforward.
Yeah, I've noticed LLMs definitely are willing to research things, right? They'll go out and look to see if there are any GitHub issues for a given problem. And if there are, and it says it doesn't work, they're like, all right, yeah, it doesn't work. I think us working to make sure that we have up-to-date docs, but my key learning of the week was make sure that I triage our GitHub issues. Because when there is a GitHub issue that says something doesn't work, but it actually does work, you definitely get a pretty bad signal from the LLM where it's not going to try a thing. So if you see me triaging inside wasmCloud and other things like that, and also removing to-dos in our code, and being really clear, it's on the roadmap item, or like this works, except this one edge case or this one variant, right? Instead of what is more natural for us previously as programmers to just be like, to do, complete this, you need to be very clear what you're doing inside GitHub issues, inside the code, because that is all now totally fair game for what LLMs are going to look at. All right. You want to see one more cool demo? I've got one more thing that I've been playing around with. So over here in SQLX, I'm gonna share my whole screen again. All right, over here in Launchpad, SQLX, I have, open in the wrong place. Going back over. Okay. I have some examples that I'm hoping to upstream to SQLX. People on the call generally know what SQLX is. Let me do a preview. Yeah. And this is in the REST ecosystem. I'll say things because some people might not be familiar. It's basically a pure REST crate that, which isn't quite true. So I actually should give them a hard time for this. It does pull in, depending on which driver you're using, it does actually pull in different types of C drivers, like the SQLite one. But if you're using Postgres, you can go down a path of a pure REST crate. And it's a really nice way to basically code to one crate and be able to point to like Postgres or MySQL. So I've created an example, and this is actually the reason why I made the call out about GitHub issues coming and biting you was actually my own GitHub issue that I had filed a while ago. In the Rust ecosystem, the Rust standard language library and Tokio and Mio and Socket 2 and all these different crates in the ecosystem have been adding WASI P2 support. And I initially ran into an issue. Well, I ran into a bunch of different ones. They've all been worked out now. There was one where this common crate that SQLX depends on for both MySQL and Postgres is called the Who Am I crate. And I tried to make that feature optional so that I could disable it and it not try to look up my username, which is obviously something that we did want to make available in a WASI sandbox ecosystem environment. So because that issue existed, I had a hard time getting my LLM to start making this. But once I created this example and then I went over to wasmCloud and I was like, hey, here's a reference example. He's like, oh, this is the standard way to create a SQLX component. And it was super happy to go and do it. So this is what it looks like to write a component in WASI P3 using native async in the SQLX. And so this is it, less than 50 lines of code. It will just, connect it. It actually uses, inside Tokio, there's the net crate, which is where they do basically their connection pooling work. And the only trick here, the only thing that like tips my hand that this is anything other than like completely off the shelf native Rust is that I basically tell it that I want a current thread excuse me, a current thread, Tokio runtime because I don't have threads in WASI P2. And so I want you to drive all of these features with pullables. There is one minor trick that's in here, which is basically to use TokioNet, I have to tell Tokio to use unstable. So they have not stabilized it yet for their WASI P2 backend. I expect that to happen over the next several months, but between this and that one trick right here, SQLX off the shelf works. And so my changes here is basically to, I like it. And so I want to put a test on it. That's called the Beyonce rule. So I'm going to put that here in their CI if they accept it, and basically validate that it works both for MySQL and Postgres. And yeah, I was pretty happy with that. That just kind of worked out. And if you want to see, if you run it later, once I put up this PR, basically all it looks like is you do a Docker run. Actually, why don't we just do this? We'll just do one of these. I'm a Docker run it. Ugh. I'm running it myself right now. Okay, I'm not gonna mess with it. This is the output that I got earlier, which is basically I Docker ran Postgres. I went and did a cargo build, and then I ran directly against Wasm time off the shelf, and connected to that local database. And then, as you saw, my little thing, it just does some addition. It's not too fancy, but enough to say, hey, it works. So that is basically the SQLX set. So once I get that up, I'll drop a link to that and the wasmCloud channel in general because I think it's cool and it's pretty exciting that it's that easy to get running with components now with the Rust ecosystem.
Bailey, that it was awesome. I have a question for you though. On the wasmCloud roadmap, we've talked about a couple of big features that are landing here to enable services. So things like implements, and then a new pass at wasmCloud host plugins, if I said that correct. It seems like if that just works out of the box, are you going to have to rebuild that once you do your host plugins and implements to support that, or is this, or will this still just work, as it is?
Well, I would say those are like pretty separate issues. But if you're confused, everybody's confused, so maybe it's worth walking through.
I understand that you'll need to make like a host plugin for this, and that implements gives you, once the ability to run multiple copies of instantiate multiple copies with different configuration. But I was just wondering if the SQLX work that you're showing here, if it's just gonna work TM as you get WASI P3 and implements and these other things across the line.
Yeah, okay, so you're talking about this feature. When I think totally separate from the host component feature. So if I write a host that supports the component model implements proposal, so component model here. Ugh. I think actually it's already merged. So it's a little bit, it's the thing about the component model repo that I don't love is that it's kind of hard to decouple, modularize the different features that we've landed inside it. It's all globbed together, so it's a little bit harder to navigate, especially for people who don't read it every day. But essentially inside WIT, we actually call it out here, I believe. And so if you look and you add something like implements, that allows you to have multiple stores that are part of your WIT definition bindings. So I can say I want to use this as other cache. And so when I build guest bindings inside my guest code, I should be able to refer to something as other cache. Today we don't have a WIT bindgen implementation of this, so you don't have a guest bindgen of it. But what we do have is the host binding side of it. So if I go to Wasm time and I go to Alex's change, implement. Oh man, it's in here somewhere. It's It's hard to find. It's in here somewhere. Basically, there's host side bindings. So wasmTime now has API on its linker to say, I've got something that says it's other cache, basically. And it's up to you to wire that up. And up to you being somebody like wasmCloud to wire that up. So inside our code, we have, let me see. I think we'll do workload deployment. And if we see name somewhere on the workload, well, we don't have it in our example, but in our spec, we have an optional field for you to basically alias an interface. And so as you import an interface, I can say other cache here. And so if you say in your workload that you've got an alias to another cache, then we can look at the host side wasmTime bindings and say, oop, that one goes there, I'll give you this one, and do that linking at runtime. So we've got work to implement that, implements, that's fun, inside the host side bindings. And I'm also picking up the work to implement implements inside the guest side binding. So that way, a single guest component can say, I have my, in-memory cache and I have my remote cache. And inside their code, they can say, right now I want to go talk to the in-memory one, and then the next call be like, I want to go to the other one. Without having guest bindings for that to express that, you don't have a way to do it currently. So that work is happening, and will be pretty powerful. So once you have that, in theory, you could wire up any kind of component. For us, we're going to start with workload deployments. But as we add things like host component plugins that are already attached to our existing plugin framework, then those host component plugins could also refer to different backends. But we can also make that work with native plugins, right? They're going to be wired up. Now, the important call out here is that these are static bindings. So the names are static. So the name would have to be, you get one Couchbase or you get one Postgres, or you've got some handshake that says they work together. So it's not going to work the way that some people might think, that they're dynamic and that you can just pass any backend and any instance of them. That's not how bindings work.
So thank you so much for that, for connecting those dots. You're right. I did not have that level of specificity, and that helps quite a bit. But then from like a platform engineering perspective, if I wanted to run, different versions of SQLX, are they going to be bound to a workload then? So would if I think of them as tenants, like team one has SQLX, team two has SQLX, team three has SQLX, and they all have three different configs. Is that how it's gonna come together?
SQLX is a library dependency of the guest component. It is not observable to the host or anybody else. So different components can have different versions of library dependencies. It's internal to the guest.
Okay. So there wouldn't be a service for SQLX. Maybe a better example might be Postgres then. So if I had three different bindings for Postgres, would they be bound on a workload level or like a team level?
Well, it depends how you build your host. So you could have a service that knows about having different bindings, and it knows about those names and implements them. So a service could say, I can implement and point to Postgres A and B. A service is workload tenant bound. You could also have your own host component when we implement that. And the host component is also something that an end user who's building it as a platform team would build for the host. And again, they would need to know ahead of time that I only support Postgres A, B, and C. And they would implement that inside their host component plugin.
Okay. I know I used the wrong words there. Thank you for your patience and helping me to actually articulate my question. And Victor, you as well in chat. I was asking about the how this is going to come together with the services. And I think ultimately I know when you get it across the line, you'll have some demos, and I think just seeing that will help just tie it all together.
And
But
today, if you wanted to do that, you would just do it with separate hosts with different configurations. It's
yeah,
kind of like what Victor's saying there. That already
yeah,
works today.
yeah, of course. Okay, thank you so much.
Hey, Ortis, how you doing, man?
Finally joining.
Got anything cool?
Only C++ is the missing one for the
Mm-mm.
maps types, but everything else is already merged. So
Oh, snap. Okay. Well, I maintain that one, so maybe I need to get my butt over there and get it done.
yeah. I need you because I don't think the people understand that. Hey, give me Ruby directions because first, I can make it work, but I don't know much about C++. And yeah.
Yeah,
Don't worry,
and
you don't want to know
nobody.
about C++.
That's what I was gonna say. Hey,
Don't
Victor.
do that. Yeah. Hey, I had a question about the basically like the essentially like database load balancer, or I don't know, maybe load balancer is not the right word, because I feel like it's not like
A
exactly a
connection
standalone service.
pooler.
Yeah, a connection pooler that's like, yeah. Anyway, about that, are there any interfaces now or planned like in the future? And I know this isn't something we thought about maybe yet, but like additional interfaces for doing like dynamic configuration of the service. Do we like? I'm not sure that's something we want or is good, but I think it would be interesting, right?
If
So like,
if the
yeah,
service imports WASI config, that's dynamic config.
yeah,
And it would know if somebody did a set on it, basically, and could react. Yeah.
yeah.
Have we
So
shown people
that's
that
really
pattern?
interesting.
No. But yeah,
Yeah,
in theory,
yeah,
it
yeah.
could.
Like that's like up for grabs, right? Like the idea of like profiles or um like different the service being able to pick up on configs, like let's say landing in Kubernetes or secrets being added, and then sort of knowing about a given profile and being able to like route requests to it. Now how the component would know like what its profiles would be and all that is a different question,
Yeah,
right? But maybe it's like
I caution using the word profiles because profiles is actually a tool convention in WebAssembly. It means something different.
oh, okay, not that. Connection configuration, sure. Connection
Yeah,
config
that
or
sounds
like sort of
good.
shared connection config, I think is what
Yeah.
we're kind of
I
talking
will
about.
say that I think dynamic config, cool. Dynamic secret, not cool. I think in that you want to roll out.
Mm,
So that can be hard though for something that you're trying to do as like a connection puller, right? Like that
yeah,
thing generally you would want to have other stuff, but what you don't want to lose basically is I want this service basically to allow me to schedule deployments. I need to know that those resources that it needs to work are available. And that's why you do that ahead of time and say like, okay, this thing ran and it connected out to stuff. Now don't schedule additional workloads on me because I don't know if I can connect to those other services, right?
and that's another thing that I think is really interesting is I think we have a new channel for like administrative control of the load balancer, because one of the things you usually do with like a PgBouncer or PgCat or whatever is actually pause connections and sort of like you have a sort of point of leverage where you can just have every uh let's say if a slow query is not downtime for you, right? This is how most people achieve their like downtime free database, migrations or whatever or changes. Like if they're going to swap out a database from underneath. So I think that's like having WIT interfaces behind that stuff is interesting as well.
Yeah, I think the like today's answer, or like not even today's answer, the tomorrow answer with we have host component plugins, we have implements, we have the ability to compile the crates that you need to actually create your own PgBouncer compiled to Wasm. Even in that world, I would actually say that I would still, if I was doing like a production at scale project, I would still actually have a real PgBouncer infrastructure there, and I would configure my host so that they can continue to be treated as basically cattle. And they always point to that PgBouncer, and the PgBouncer is the thing that I changed because you're going to want to deploy those to each edge or each zone. I mean, I'm talking global scale for that, like baby scale, sure, use the component, but for massive scale, I still think that you want your host to basically be the cattle. You don't want them to be the critical load balancer yet. And for those types of things, there's very, very, very specialized implementations that people use. That we don't have the expressivity yet, I think, in the WebAssembly runtime side of the world to be able to have something that's long running like that.
Yeah, that's interesting. It's like, I wonder if it's an interesting way. It's interesting as a way to like control the like as a control path for the cluster. So like normally you have to have, like, let's say if you have this external PgBouncer, or like the usual kind of setup now, you need this sort of like other control plane to like send the pause, let's say, like to like just make sure you're either like not, you're just sort of not letting requests go through, right? Then you do the switch over or whatever, and then you like let requests sort of go again, you unpause them. I wonder if, because like what happens when you hit pause is completely up to the host, right? Like if the service decides to call out to an actual PgBouncer and do the pause, like that's interesting too. Like that's also technically possible. But I wonder if it's interesting to like with a workload deploy not only the clients that use the database, but the sort of like management interface as well. Like, is that interesting? Because it's like,
yeah, I think you could do it as a host component. When we have host components.
Yeah,
and
we have host components.
And I mean, our host components do already have lifecycle built into them for like a shutdown API or on workload bind. So you do know when new people are added, and that you're servicing them. And right now we're very much bound to a very specific, I'm going to use the word profile inside our host where like we're very geared towards, let's say, like an 8 GB RAM 6-core host. Wasm time is like what we're profiling against right now. And so that would be good for just servicing that workload's host, right? Like you could easily have a host component that can handle the couple hundred of components that are clients and running through it. That's fine, and that's what we're really designing for. I still kind of like caution on the like, okay, we're doing a database A/B migration across the globe in that world. That's why I'm like, ooh, I want that one kind of to be more external to like the thing that's the client side connection pool is what we're aiming for, right? I do think that because you have start, stop, because you know who's implementing what, and you have tendency for like you could even do it by data, like in a managed database. You also have the concept of other databases that you connect to inside that one managed database. I got to explain that because I know you know, but maybe not other people know. But as part of that, we can do that as part of the implements API, and we can talk to different ones.
Do you mean, if you're talking about Postgres, do you mean the cluster?
Yes.
Multiple databases in the same cluster, because every single Postgres instance is actually a cluster, which is what they chose to name it. But yeah, that's interesting. But yeah, this is all around like awesome feature. Pretty excited.
I think we should keep pushing in that direction, I guess is what I'm TLDR. We should keep pushing. I'm not going to tell people to do it, yet, but soon, maybe. Yeah, and I mean, there's also plenty of distributed databases that are also of interest that would be cool to add. And again, now we don't have to bake in all these different people's dependencies into our tree. People can just rock up with whatever esoteric database they want. Although, the only answer, as you said in chat, is Postgres. But if they wanted, they could easily and have support for a lot of different ones. And yeah, we wouldn't care. It's just a socket.
Okay, but the real question is it a cluster or not? What would you call it? Let's fix this for Postgres.
Oh gosh, I don't know. My brain is still in MySQL land with single store. That's the wire protocol we did, and we didn't.
I mean, if you say cluster to me, my brain goes out of like multiple nodes, Active one. Like nothing is related to, oh, here's a cluster database. It's like, okay, please rename it.
Yeah, it's a super old Postgresism that like immediately confuses anyone that sees it in at any point after like 2008 or 10 or
Okay,
whatever.
that makes sense because in 15 years we didn't even have multi-node type of problems. It's like single box, call it a day.
As long as they don't rename it to component or instance, I will be totally fine.
I would hate the person, probably was Bailey, that name wheat world thing.
That wasn't me, man. That wasn't me. I pushed back.
That
I said, "That's
person, I'm
weird."
sorry, I'm not
That's
gonna give you
weird.
flowers.
I actually suggested that should be profile. Which is really funny. But then they were like, no, profiles we're trying to make that be a different thing in WebAssembly tool conventions. So potentially profile might also be one of those overloaded words.
That person definitely didn't Google what are the top three most difficult word to pronounce in English.
Yeah. Yeah. I mean, we have plenty of impossible to pronounce words
No, but
that
that
don't
one is
follow
the one of the top
rules.
ones.
Yeah. I mean, part of me says worlds themselves inside components kind of fades away, and you're just talking about the component that you're targeting, and the platform that you're targeting, because you're going to be able to run anywhere. And it's going to be less interesting to you, I think, for the specific name of the world, so much as is the environment that you actually just want to run this thing in. That's maybe overly hopeful, but I kind of wish that would fade a little bit further into the background as these tools just work. That was fun. All right, y'all. We've got 3 minutes left. I think I'm gonna call it. It's good. Good call today. See you next week.